Hey guys, today we're going to talk about the transversal. A transversal is a line that cuts through two or more lines on the same plane. In our case, we're going to talk about a transversal that cuts through two parallel lines. Okay, and then the board I have up here, the transversal is line AB. So from the transversal, we can talk about our angles that we've been working with. Okay, so here I have labeled the angles with the numbers 1, 2, 3, 4, 5, 6, 7, and 8. And I've kind of color-coded them to show you which angles will be congruent. So we know that supplementary angles equal 180 degrees. And we know that these angles here, like angle 1 and angle 2, they are next to each other. They are adjacent angles in this case as well. Angles 1 and angle 2 will, their measures, the sum of their measures will equal 180 degrees. The same thing with angle 3 and 4, and then 2 and 3, and then 1 and 4. And then if we look on the other portion, the other half of the transversal, the same thing carries through. Angle 5 and 6 are supplemental, angle 6 and 7 are supplemental, angle 7 and 8 are supplemental, and then angle 5 and 8 are supplemental as well. There may be times where angles are complementary, but we're not really going to focus on those. Remember that complementary angles are angles that have measures that are, their sum of their measures is equal to 90 degrees. Some other angles that we've worked with are vertical angles. And vertical angles, they share the same vertex and are directly across from one another. So you can see on the board there, again color-coded, angles 1 and angle 3 and angles 2 and angle 4 are vertical angles. They will have congruent measures. And on the other portion of the transversal down here, angle 5 and angle 7 are vertical angles, as are angle 6 and angle 8. And remember, again, vertical angles will have congruent measures. Some new angles for us to work with are alternate interior. Okay? Alternate interior angles. They alternate across the transversal, and they are on the inside or the interior of the two parallel lines. And you can see that I have angle 1 and angle 4 in purple, and I have angles 2 and angle 3 in orange. Those are alternate interior angles. So we talked about the interior. Let's talk about the exterior. We have alternate exterior angles. Alternate exterior angles, okay, again, go on either side of the transversal. This time they are on the outside of the parallel lines. And you can see that I have angle 2 and angle 3 on the opposite sides of the transversal, on the outside of the parallel lines. And then I have angles 1 and angle 4 indicated as well. Finally, we have corresponding angles. Now, if you look at the transversal, you may have noticed that they're pretty much, the transversal line pretty much makes two identical figures. Okay? There's the one on top here and the one on the bottom there. So I have used 4 different colors to show the corresponding angles. And so basically the corresponding angles, for lack of a better term, will correspond with the same angle in the same place on the other half of the transversal. So I have angles 1 and 5 and angles 2 and 6. They're both in the, angles 2 and 6 are both in the upper right corner of the transversal line cutting through that parallel line. Okay? Then we have angle 4 and angle 8 and angle 3 and angle 7. Those are corresponding angles. Okay, so using our knowledge of these angles, we can determine angle measures. Okay? So, again, I have my transversal drawn, and in this case, I've got angles 1, angle 3, angle 5, and angle 7 in red, and angles 2, 4, 6, and 8 in blue. Again, showing the angles that would have congruent measures. So if we said that the angles who have the same color have congruent measures, if we said that angle 2 was 80 degrees, that would also make angle 4 80 degrees. And that would be through vertical angles, okay, because they are vertical, directly across from one another, sharing the same vertex. Similarly, angle 4 and angle 6 would have the same measure. They would also be 80 degrees because of alternate interior angles. And then again, if we wanted to find the measure of angle 8, if we know that angle 6 is 80 degrees through alternate interior angles, then angle 8 will also be 80 degrees through vertical angles. We can also say that angle 4 and angle 8 are corresponding angles, and if one of them is 80, the other has to be 80 as well. Same thing with angle 2 and angle 6. So we know that the blue angles are 80 degrees. If we wanted to find the measure of the red angles, we would find its supplement. So if the blue is 80, and we know that this entire line here, which encompasses, say, angles 1 and 2, needs to be 180 degrees, we would take 80 degrees away from 180 and be left with 100. So angle 1 would be 100 degrees through vertical angles. Angle 3 would be 100 degrees. If we come over and look down at angle 5 through vertical angles, angle 5 would be 100 degrees, and then angle 7 would be 100 degrees as well through vertical angles. And again, we could also say that angle 3 and angle 7 correspond. They should be the same measure, and that angle 1 and angle 5 correspond, and they should be the same measure. Things get a little trickier when we have expressions instead of actual angle measures. And with this transversal, I've actually cut it in two because there's two different pieces to this. So this one here, up on the top, I have the angles 1 through 4. And angle 4 has the expression x plus 15. Angle 1 has the expression 2x. And we know that angle 1 and angle 4 in this case have to be supplementary. They have to be equal to 180 degrees. So the sums of those two angles will equal 180 degrees. So we set 2x plus x plus 15 and set that equal to 180. Combine like terms, we have 3x plus 15 is equal to 180. Subtract 15 from both sides, we get 3x is equal to 165. Divide by 3 on both sides, and we get 55. We go back and check. 55 plus 15, replacing 55 for x, we get 70. 2 times 55 is 110, and 70 plus 110 equals 180. So that will work out. On the bottom here, I have a case of vertical angles. I have two expressions that are vertical. So we know that vertical angles are congruent or equal to each other. So that's what we're going to do. We're going to take the expression x plus 20 and the expression 3x plus 10 and set those equal to each other. So from here, we're just solving, or we're just balancing an equation. We subtract x from both sides. We're left with 2x plus 10 is equal to 20. Subtract 10 from both sides. We're left with 2x is equal to 10. Divide by 2 on both sides, x is 5. Let's go back and double check. Remember, those angles measures should end up to be the same. So we have 3 times 5 plus 10. So we have 15 plus 10 is equal to 25. And that would be for this one. So 3 times 5 times our x. And then we come over and look at the other expression. We replace x with 5. So 5 plus 20 is 25. And 25 does equal 25. So that works out well. Okay, so we're going to practice a lot more with this in class, and then we're going to expand on this once we get to triangles, but this is really the basics. I look forward to working with you. Os!